In a quiet lab filled with the hum of servers and the glow of monitors, something extraordinary just happened. For the first time, an AI didn't just analyze cancer data, it discovered a potential new pathway for treatment. This isn't science fiction. This is Google DeepMind's latest leap. A model so advanced it may have found a way to help the immune system see tumors that were once invisible. And it's not just Google. OpenAI, Isomorphic Labs, and even Jeff Bezos-backed projects are now turning AI into something new, a scientist. Today, we're diving deep into how artificial intelligence is transforming the future of science, from curing cancer to reversing aging and even controlling fusion energy. Welcome to a new era, where machines don't just follow instructions, they make discoveries. The discovery: Google DeepMind and the cancer breakthrough. Let's start with DeepMind, the AI powerhouse behind AlphaFold and AlphaGo. Their new model, part of the Gemma family, is called Cell-to-Sentence Scale 27B. That's 27 billion parameters trained entirely on cancer data. What's remarkable? This AI didn't just predict existing medical knowledge. It discovered a new, previously unreported drug mechanism. And yes, it was validated in the lab. Here's what happened. Researchers were testing whether certain drugs could help the immune system detect hidden tumors. Normally, some cancer cells can cloak themselves, avoiding immune detection entirely. But this new AI-designed drug, when combined with a low immune signal, caused tumor cells to expose themselves, up to 50% more visibility under immune scans. In other words, it made the invisible visible. A simple, targeted drug made the body's defense system suddenly recognize and attack what it couldn't see before. That's revolutionary. This could open a whole new direction for cancer therapy, not just killing cancer cells, but revealing them. The model behind it, Gemma 27B, may represent the first time an AI has directly contributed to the conceptual discovery of a biological mechanism. The foundation: a decade of DeepMind's biological models. Of course, this wasn't luck. DeepMind has been building toward this moment for a decade. They've already developed several groundbreaking systems: Deep Variant, Alpha Missense, Deep Somatic, and the legendary AlphaFold. Deep Variant transforms DNA sequencing data into visual patterns, spotting genetic differences across individuals. It's used to identify disease risks and inherited mutations. Alpha Missense predicts whether a single letter change in DNA, one base pair, could cause harm or remain harmless. This helps diagnose rare genetic disorders faster than ever. Deep Somatic focuses on mutations that appear later in life, mutations within cancer cells. It identifies which genes play key roles in the tumor formation. And of course, AlphaFold predicted the 3D structure of proteins with near-laboratory accuracy, an achievement hailed as one of the biggest scientific breakthroughs in recent history. Together, these systems formed the groundwork for the new Gemma model, a model capable not only of analyzing biology but hypothesizing new mechanisms. And that changes everything. OpenAI's move. The science frontier. While DeepMind explores biology, OpenAI is taking a different path, bringing AI into theoretical physics, mathematics, and biotechnology. Recently, OpenAI hired Alex Lupsasca, a physicist known for his work on black holes. He's now the first official scientist in OpenAI for Science, a division dedicated to building AI tools that accelerate research itself. The mission? To make AI not just a writing or coding assistant, but a genuine scientific collaborator. We're already seeing results. Mathematician Terence Tao, one of the most brilliant minds of our time, used GPT-5 to test open mathematical problems. He said the model helped solve a complex equation in minutes, a task that would normally take hours. Meanwhile, Scott Aronson, a leading expert in quantum computing, used GPT-5 thinking mode to generate new mathematical functions that actually worked in real-world quantum experiments. He described it as a partner that moves you forward when you're stuck. This marks a turning point. AI isn't just calculating, it's reasoning. OpenAI's biological. Project Reversing Aging, but the story doesn't stop there. OpenAI has also teamed up with Retro Biosciences, a longevity startup backed by Sam Altman himself. Together, they've developed a biology-focused model called GPT-4b Micro. Its mission: to optimize something called the Yamanaka factors, 4 genes discovered by Nobel laureate Shinya Yamanaka in 2006. These factors, when activated, can reprogram adult cells into stem cells, essentially reversing their age and resetting them to a factory default. The genes, OCA4, ESOX2, KLF4, and MIC, allow skin or blood cells to transform back into versatile stem cells that can become any type of tissue: nerve, muscle, or skin. Now, OpenAI's GPT-4b Micro is helping scientists design improved versions of these proteins. In lab experiments, these new AI-designed proteins sent rejuvenation signals 50 times stronger than before. DNA repair accelerated, and old human cells, taken from people over 50, started behaving like young cells again. Within 7 days, over 30% showed rejuvenation. After 12 days, 85% resembled youthful stem cells. It's early-stage science, but the implications are staggering. AI isn't just helping us understand biology, it's helping us reprogram life itself. The rise of AI scientists, periodic labs, Lila Sciences, and beyond Google and OpenAI. The scientific AI revolution is exploding. Periodic Labs, funded by Jeff Bezos, Eric Schmidt, and NVIDIA, recently raised $300 million. Their goal? Create AI scientists, autonomous systems running experiments 24/7 using robotic labs. These systems can generate hypotheses, test them, analyze results, and iterate, all without human fatigue. Similarly, Lila Sciences is building AI-driven research pipelines capable of discovering new molecules and validating them in robotic experiments. It's the fusion of artificial intelligence and real-world science, machines not just simulating ideas, but physically testing them. And over at Carnegie Mellon University, a new project called Emerald Cloud Lab lets researchers control 200-plus robotic instruments remotely, running real biology experiments entirely online. Students can now conduct complex molecular research from their laptops, anywhere in the world. It's science without walls, AI and fusion energy, powering the future. Now, let's talk about something even bigger: fusion energy, the power of the sun. DeepMind has partnered with Commonwealth Fusion Systems to make it a reality. Their goal: build a reactor named Spark that can generate more energy than it consumes, a milestone called net energy gain. Fusion is simple in theory: combine hydrogen atoms and release massive amounts of energy. But maintaining a plasma at 100 million degrees Celsius long enough for fusion to occur is one of the hardest problems in physics. DeepMind's AI is tackling it head-on. Using reinforcement learning, their system can control magnetic fields inside a tokamak reactor to keep the plasma stable. In Switzerland's EPFL labs, it already succeeded in balancing plasma for several seconds, a critical step forward. Now, they've developed a new system called Thorax, capable of running millions of virtual fusion experiments before Spark even turns on. It predicts which magnetic configurations produce maximum stability and energy output. If it works, it could accelerate fusion research by decades and bring humanity closer to limitless clean energy. The bigger picture: AI as humanity's research partner. When we step back, a clear pattern emerges. Artificial intelligence is no longer just generating images, code, or text. It's becoming a co-scientist, a thinking, reasoning partner that accelerates discovery. We're talking about AIs that detect hidden cancers, reverse cellular aging, simulate nuclear fusion, and generate new mathematical theories. That's not automation. That's acceleration. If this momentum continues, AI could soon make today's toughest challenges: cancer, aging, energy scarcity solvable within our lifetimes. Problems that seem monumental today might become minor scientific exercises tomorrow. Of course, every leap forward brings risks. As Mustafa Suleyman, DeepMind's co-founder, warned in his book The Coming Wave, AI could deliver abundance and health, but also unleash unpredictable dangers. That's why humanity must shape AI's path carefully, so that our new digital scientists work for progress, not peril. So, where are we heading? We're witnessing the dawn of something extraordinary. AI is no longer an assistant. It's a collaborator, a scientist, a partner in human discovery. It's accelerating science, decoding complexity, and helping us reimagine what's possible, from curing invisible cancers to unlocking the power of the sun, to rejuvenating life itself. We're standing at the edge of a new scientific revolution, and maybe, just maybe, the next great discovery won't come from a human mind, but with one.